We need to think about this, okay? I'm asking you to do it as a tree diagram. In this case, you could actually just write all the different possible outcomes, but just think, if you were going to write, if you were just going to list all of the different possible outcomes, why would that not be the best method? And the same thing for a dot diagram. Why would that not be the best method? So writing them or a dot diagram in this case. It does take a lot of time, but also, if I now want you to do something with the chance of it happening, can you do that from here or here very easily? No. Not particularly, because actually in this case, they're not fair. Okay, so in other words, the chance of you taking a blue sock is not the same as the chance of you taking a red sock. So it's not just as simple, so it's harder to pull this out. Whereas the advantage of having a tree diagram is that you actually have the probabilities to work with. Okay, and you know how to combine them. If it happens together and situation, you multiply. If it's one or the other, it's an add. Okay, just think. Okay, you can either take blue socks or green socks. 2 socks are taken at random. Okay, so we're going to think about this as a separate pick. So let's say the first set of branches represent the first pick. Okay, which socks can we take out? So how many socks can we take out? So what are the different outcomes? Yeah, we can either take a blue sock or we can take a green sock. Let's actually fill in the probabilities whilst we're at it. What's the probability of taking a blue sock out?
3 over 5.
Good, a 3/5 chance. Yeah, three blue socks out of 5 in total. Probability of green?
2 over 5.
Good, and just check. Good check. Do these add together to make 1? Yeah, absolutely. So we know we're in business. Okay. So now let's say that we go and take another pick. Okay, so we take another sock out, right? Now, are you happy that if we take a blue sock out, we can still take 2 socks out? We can still take another blue, or we can take a new sock. We can take a green. Okay. But let's think here. Let's think. What's the probability of taking another blue sock out, given that you've already taken a blue sock out?
2 over something. 2 over 4, yeah.
Why is it 2 over 4?
Because we already took a sock before.
Which colour?
Blue.
Blue. So we've already taken a blue sock out, which means there's only 2 blue socks left in there. Yes, there's 2 favourable outcomes. And also, because we've taken a sock out, there's only 4 socks left. So it's out of 4. What's the probability of taking a green sock?
2 over 4 as well.
Good, because there's still 2 green socks left, but there's now 4 left. Okay? But now, let's scratch that. Let's imagine we took a green sock out on the first go. Are you happy we can still take either a blue sock or another green sock? Okay?
Yeah.
So what's the probability of taking a blue sock, given we've already taken a green sock?
3 over 4.
Good, because there's still 3 blue socks left in there, but there's now only 4 left. What's the probability of taking another green sock? 1 over 4, because we've already taken a green sock out. It's as simple as that, okay? So you should end up with something that looks like this, okay? Does that make sense? So you see on the screen, all I've done there is I've just illustrated what you're doing at each stage. This is at the start before you've taken any socks out. That's where you always start from. Then you just represent the different possible outcomes that you can have from here. Is that okay? Yep, good. Fantastic. So, you should get that. You should get that. Okay. Can you have a go then? In fact, let's go back to this. Can you find me the probability of taking socks of different colour? So can you find me the probability that you pick 2 socks out at random, but the socks have to be different? What's the probability of that happening? Okay, so we want the probability that the socks are going to be different. So we just need to think about this, and we just need to think about all the different situations that we can get different socks. Now remember, we have to take 2 socks out, so we need to consider over this side. Okay? If we're sitting here, what have we done? If we're sitting here, what have we done?
Blue sock.
We've taken a blue sock out and then another blue sock. Does that mean the socks are different? No. So actually, we're not interested in this situation here. Okay? Likewise, if we're sitting down here, what have we done? Good, we've taken 2 green socks out. Not interested in that. Okay?
3 over 4 and 2 over 4.
Well, let's check. So if we're sitting here, what have we done?
Oh, wait. 2, yeah.
Yeah, we've taken a blue sock out, then a green sock. So we definitely want this one. What about this situation?
Yeah, that one as well.
Yeah, because we've taken a green and then a blue. Okay. So first thing, go through your sample space, go through the thing over here, and find what you're interested in. Okay, maybe just put a little tick and cross like I have. So we need to find the probability that we end up here first of all. In other words, what's the probability that we take a blue sock first, followed by a green sock? Okay, so how do we work out that probability? Good, we take that probability, which is 3/5, and we multiply it, we work our way along, by that probability, 2/4. What's this equal to?
6/20.
Keep it at 6/20 for the time being, and you'll see why in just a second, okay? Okay, what about the probability of getting this? So what would the probability, what would the event be?
Green and blue.
Good, green and blue, yeah, green and blue, okay? So, what do we do to these two probabilities? So 2/5 and 3/4.
Multiply them again.
Okay, what do we get?
6/20.
Good, 6/20, okay, 6/20. So now, how do we combine these probabilities together? So this is one outcome that we could have where the socks are different. This is another outcome that we can have where the socks are different. Can they happen at the same time? No, we can either have this one or this one, but not both. Okay, we can't have blue first, then green, and green first, then blue. Okay, so therefore we're going to have to add these two probabilities together. Okay, so we're going to take 6/20 and add it to 6/20. What's this equal to?
12/40. 12/2.
12/20. Now you simplify. Leave your simplification till the very end. Okay, so what's this equal to?
6/10. 3/5.
Good, 3/5, yeah? Which is about 60% if you put it as a percentage. But effectively, what this means is that if you were going to take 2 socks out 5 times, okay, so you took 2 socks, then another 2 socks, then another 2 socks, then another 2 socks, and another 2 socks, you would find that 3 of those times, on average, should be where the socks are different. Does that make sense?
Yeah.
Okay. So just one final thing and then we'll take a break. Yeah, we need to take a break. If you're working across the branches, so you're working from left to right, so this probability and this probability, you should multiply. Bless you, bless you, bless you. And if you're working down, so you're taking this probability and this probability, you should add. Okay, so it might just be an easier way to remember that.